All right, so if you're an online kid watching this amazing video, I hope you enjoy it. The first thing we're going to do is take the how fast energy diagram quiz on Canvas. Now, everyone in this room already knows that, but that was for online because I forgot to record. All right, so let's go ahead and if you're online, pause it. If not, here we go. So let's see how this went. Trimester, here we go. How fast, energy diagrams, quiz statistics, please be above 70. No, I'll take a 75. High score. That was Odessa. Was it Odessa? Did you get 96%? All the peer pressure right now. She's like,
I only missed the catalyst question. I don't know if I got
okay,
96.
that's a 96. Okay, let's talk through it. We will learn about catalysts, so don't freak out. I didn't realize that was on that. There were two other questions on catalyst in that I removed. I just didn't notice that one at the bottom. Okay, so our mode is 96. My heavens. What?
Mode.
Big word. Mode. It means
It's a math term, I think.
it means the most repeated value.
It's the most common thing.
Most repeated value or most common thingy.
Yeah.
Okay, here we go, my friends. Starting energy. All right, this was the tricky one, but not hard. If you missed this one, I love you, but read. Draw a basic energy diagram of reaction that has a starting energy of 20. I mean, come on. I've made this class easy. That one gives you the answer word for word. Who are these people? JK. All right. Now, the ending energy. Yeah, what? How is it 10? It loses 10 overall. It does. Let's draw it. All right, where did it start? 20, and then it goes up to what number? 28, and then it loses how many overall? 10.
If you minus from the 28 overall, it only.
Remember, the energy lost or gained goes from where you started to where you ended. See, that's why we quiz. You won't miss that again, right? All you O's. All right, so that was 10. All right, this value is the activation energy, which was 8. All right, a catalyst. We will learn, let's look at the screen for a minute. A catalyst lowers the activation energy. So the bump gets a lot smaller. So instead of 28, it would have been 24, 22, or whatever. If 8 was an option, that would have been the answer. That's what I told Curtis, but it wasn't on there. So whatever.
I need Bella Gilbert. That's me.
She was just drinking water, so she is set.
Taking care of it. Thank you.
Bella, chug.
Don't forget your water. You're gonna need it.
Oh, man. Oh, hey, Kyrie Parkey. Oh, man, why did I lift weights? I'm such an idiot. Oh, my back, my neck, my shoulder. Life sucks getting old. Okay, whoops, I need to go here. Okay, highest point on the graph, that's 28 because that's the 20 plus the 8. Endo or exo, it lost, so it has to be exo. Then we struggled here because I told you the wrong answer. These people took it after, so congratulations to all those awesome people. All right, here we go. The energy diagram above shows the energy pathway of an endothermic reaction. Good, very good. This one showed an exothermic reaction. Then the math. And some of you, remember, I don't make you take all of them on the practice. So some of you maybe didn't get all these. That's fine. Okay, so this is the math one. What is the value of the activation energy of the above reaction? So that's just the length of letter D, right? So it was 8, went to 13. I would say that's 5. Fair enough. You have a range of answers, so it shouldn't be too bad. Ooh, then labeling it. So it really bugs me. Canvas won't, it doesn't do A, B, C, D, E in order, which is just dumb, but whatever. So we start with D, that's over here. That's the energy of the products. Did it offend you that I just put products? Were you okay with that? All right, because the what do we call these things? Oh my heaven. The axis is energy. So it really means energy of products. All right, my reactants, that is A. Activation energy is C. Some of you probably put B. Ooh, lots of you put B. The distance here is the activation energy. Letter B is what we call the activated complex, or the unstable arrangement of atoms at the peak of the activation barrier. Ooh, I nailed that matching term, in case you wondered. Oh, maybe I should take a nap. I should just blame it on the vaccine. They're like, man, I don't feel good because I'm old. All right, energy gained or lost. That's, well, there was no winner. There was only losers. So if anyone called in a sub today, they had to buy us all shakes. Well, not really. It's for this week. So hopefully I don't like break my arm today and have to call in a sub. Knock on wood, even though this is fake painted wood. All right, and or exo, that is exo because it's lower. Okay, these, what? No, it's not even remotely wood. It's a composite material. Sorry, I ruined your life.
You're lying.
Try and light it on fire. Don't really. You really have.
Imagine I pull out a lighter. No.
Oh.
I gotta examine. No,
Everybody,
it's not true.
this is not wood. It was formed as a liquid inside a form, and then it's set as a solid. It's made out of.
Wood with some like a nice coat on it.
No, it's a resin. It's like a bowling ball more than it is a wood.
I love bowling.
Oh, welcome to class. I didn't see you over there. No? Do you think Mr. Call was impressed with my teaching location? Just hanging out with my feet up on the desk. That's sad. It's Mr. Taylor's friend. I know. I know. He actually speaks extremely highly of you. He nominated you as student of the month or something. Yeah. Probably for attending and walk. No? Okay. Okay, this was here. So from 4 to 8, so it should be 4 or 4:20. Okay, my friends, this is on the exam. You have to get above 80% to get full credit. Could you get 80%? I should refresh it now. Woo! Tanner. Oh, never mind. Who did it? We got a hundo. Probably someone taking it while I told them all the answers. Kennedy Vaughn. Okay. Okay. Oh. Okay. That's that. Hopefully you feel like you could do that successfully on an exam. If you don't feel like you could do it on an exam, you need to study. You need to come in, you need to get help, you need to do all those things. Okay, so plan for today, check. We did that. We averaged 75% first hour. Oh yeah, we got 77. Oh boy, that's, you can't cheat from a 5 to 7. We'll say it rounded to 78. We okay with that? Yes way. You would never know. You would never know. I went to high school too, kids. Okay. Now, catalysts today, we ready? Those are on page 4, maybe 5. How am I taking so slow to do this book? Oh, I know why. It's the vaccine. Wow, you took the words out of my mouth. The microchip in my brain now is slowing. So that was not funny. Okay. Catalysts are pretty easy. So let's just dive in. I have the notes right here. A reaction can be made to happen faster. That's really not going to get any bigger. Faster is the key word here. By the presence of a catalyst. A catalyst is a substance that increases the rate of a reaction without, is that two words? It is one word? Okay. English is definitely my weakness. Without being used up itself in the reaction. A catalyst provides a surface where the reaction can occur at lower activation energies because the reactants are brought in close proximity to each other in a correct molecular alignment that allows bond formation or breaking. Okay, this is a matching term. What color do we feel like today? 7. 1, 2, 3, 4, 5, 6, 7. All right. This is the matching term right here. A substance that increases the rate of a reaction without being used up itself in the reaction. That's your matching term. All right. Now, my example of a catalyst isn't really a catalyst, but it works good enough if you'll just go with me here. When I eat cereal, I pour it into a bowl. Whatever cereal you like, that's what I'm drawing. Yep, Reese's Puffs now. All right, I pour it into the bowl, I put some milk in, and then I use this device called a spoon. We okay with that? I use a spoon. This spoon is sort of like a catalyst. Why? Because the spoon helps me to eat my cereal, but I don't eat my spoon. We okay with that? Nope. Only weird people do. Okay. So. Sharon Torrey. That was not very nice. There isn't always one. Most of them don't have one. So to answer that question, there's no real answer. But I will show you a demonstration that has a catalyst right now. All right. So up in the front, you don't have to write this down, but I'm going to take what we call hydrogen peroxide, which is H2O2, and I'm going to convert it to water and oxygen. We okay with that? Now, this process happens naturally. Anyone remember when you buy hydrogen peroxide, what color the bottle is at the store? It's dark brown. It is opaque. It's opaque for a reason, and that's just because visible light can come and it can hit this and cause this reaction to happen. So we keep it away from light. All right, now that doesn't happen very fast. And your bottle, if it was a clear bottle, well, that's not bad for me. It would just have bubbles like stuck to the side of the wall. You with me? And that wouldn't be very entertaining, but that's what would happen. The oxygen would just come out, it'd form little bubbles on the side of the wall, and that's life. All right, but I'm going to add a catalyst to this reaction. A catalyst is often written on top of the arrow because it's not really a product or a reactant. It's just something that helps the reaction to happen faster. By adding potassium iodide to this solution, the rate goes from about, I don't know, what is it, 10 to the negative 3 or something like that, to around 10 to the positive 4th. So that's 7 zeros, 1, 2, 3, 4, 5, 6, 7. It gets that much faster. So all the bubbles come out 10 million times faster. Sound good? All right. You have seen this on the internet, by the way, probably. Anyone know what this reaction is? Elephant toothpaste. All right. You thought what? I have the stuff to make elephant toothpaste. I'm gonna do it right here. Oh my. What are the odds? Well, you're in a chemistry class, so they're pretty high. What? Why is this being done? Okay. Here we go. No, that would burn my hand. Whoa, whoa, what's going on here? Why? It puts off heat because it's an endothermic process. This is really annoying. Why? Oh, hey, I look overweight. I am not overweight, so I don't know why I would look that way. Hey. Okay, fine. I wish it would just show on this screen. Do I just double click it? That works on the iPad. Oh, I do that. No, I don't. I'm annoyed. I did, and then it just does it. It splits. I guess that's better. Oh, never mind. Ask Bert. Oh, kids these days. I don't ask Bert for anything. He tells me what he wants me to do, and I do the opposite. He's like my parent. Okay, now I had this all set up for yesterday, so I might need to. Yeah, it was a sad day. Okay, so this is potassium iodide. I already added some to this yesterday. By the way, potassium iodide is really good at absorbing water from the atmosphere, and it turns into a solid. In case you're wondering why I'm stabbing you. Okay. What? Oh, you can eat this stuff. It's not that big a deal. Like you wouldn't want to eat very much of it. No. All right, so this is potassium iodide. You passed again. Good job. Okay, to make this cooler, and hopefully it even works. You know it. All right, now I have soap in there. I have food coloring in here. In there, I'm going to add some hydrogen peroxide now. Now, it's not like what we saw on the TV. I'm sorry. Well, it's kind of expensive to make. All right, so I just did that to mix the soap up, and then I will add the potassium iodide. All right, it is like a volcano that just keeps on going.
It's hot.
How can you tell it's hot? You definitely can see steam. No, it's hot, and it's full of a chemical called hydrogen peroxide if it didn't get all consumed. Okay, now, I know that wasn't as cool as the internet, but most things aren't as cool as the internet, right? Who's seen elephant toothpaste on the internet? Good, because I showed it one day. And yeah, I did. The Mr. Beast video. Yep. All right. So this is elephant toothpaste. It is what happens when we use a catalyst to speed a reaction up. Because this stuff is just doing nothing. Like it slowly decays over time. I shouldn't say decay. It slowly decomposes over time. All right. You see this rag? So it got food coloring on it too, but the hydrogen peroxide, when it's this concentrated, can you see it like kind of ate the fabric a little bit too? That's why I won't let you touch it. It eats your skin. Okay, can anyone tell me what's in the bubbles now? Water and it'll be all right. I'm gonna light on fire. All right, Spencer, you turn the light off for a second. Like it's hot. Like it's hot. All right. First, I'm just gonna go like that. Oh, that didn't work at all. That was not. You're welcome for my coolness. How about over here? There we go. You see how it makes the thing burn faster instead of going out? So I just dropped that in water, but it wasn't really water. It's more what element? Oxygen. The top of the tube, I guess, had a little too much water. That's why it went out before. We can just light these bubbles on fire and you'll see it speeds up the combustion. The combustion of the match because I supply it oxygen. Cool. Okay. So that's an example of a catalyzed reaction. That's a reaction that is sped up because we used a catalyst. No, you can't touch it at all. Sorry. Okay, now, next little part of catalyst is pretty interesting. I have a little video that you may or may not find interesting. But luckily for me, I'm not really worried if you care. I don't know. When you're super good looking your whole life, you realize you just don't really care what people think because you know you're beautiful. Yeah, only Jared would understand, right? Okay, I need to share my screen again. Yes, sir. I don't know. Thought we already did blow stuff up. Okay. Next, we'll get the blanks real quick. So enzymes are Mother Nature's catalyst. You should have learned about them in biology last year. If you have med term or whatever, map, they're all the ACEs. Is it ASE? I think it is. Like lactase, stuff like that. Instead of 8, it becomes an ACE. All right, enzymes are chemical regulators. Did anyone pig out after the Super Bowl and just not feel very good? Besides me. All right. You're flooding your system with food. You're throwing down drinks. You're doing whatever. And honestly, half the time you don't feel good, it's because you have messed up your enzyme system. And you are not regulated normal. So your body takes care of that, usually by forcing things out somewhere. Okay, moving on. They are natural. Yep, you got to get rid of it one way or the other. They are natural catalysts. All right, so you might remember this. The substrates are the two things that are going to react. The enzyme has an active site. That's where it provides a surface for these things to meet. That was a poor color choice. All right, it brings in the two reactants. In biology, they're called substrates. It puts them together and then it breaks back off and we have the product which we wanted, and then the enzyme is completely the same as it was before, ready for the next one to happen. All right, enzymes are awesome because they lower the energy needed to activate or start a chemical reaction. Next, they are highly specific. Ooh, that's gonna be hard. Catalyzing only one particular reaction. So we have tens of thousands of catalysts in our enzymes in our body because we are a chemical machine over and over and over. For me right now to talk, to move my arm, to think, all that involves chemistry, and all of that is helped with catalysts or enzymes. I keep saying that. All right, temperature. Temperature affects enzyme activity. It increases with higher temperature, but high temperatures can inactivate enzymes. So anyone ever had a high fever and you weren't hungry at all? It's pretty common. Once you get, so if you have a temperature of like 99 to 100, you're fine. Nothing's way off. Get much higher than that, then your enzymes get inactive, and then you don't really digest your food normal. So there's no trigger that says, hey, you got to eat, even though you still definitely need to eat. So it's just your enzymes are out of whack. They have an optimal pH. pH is the measure of acidity in your body. All right. And if you mess that up, you definitely will mess up your enzymes. 7 is neutral. 1 is an acid, like really strong. 14 is a really strong base. The fastest way that human beings choose to mess with their pH is to drink alcohol. That's really bad for your body, whether you enjoy it or not. It is bad for your body. You're changing the pH over and over, and your body can become dependent, and you can have permanent changes happen to your body. That's part of it, absolutely. All right, these can be inhibited. That's too big, so by certain chemical agents. So once again, that's like drugs or alcohol or certain medications. You know, sometimes, and I don't know, but I'm super allergic to like every pain medicine ever. So if it has anything that ends in all in it, I cannot take it. It makes me throw up like crazy. And I don't know, but I assume it probably has something to do with my body reacting to these in a way that it shuts down my enzymes. So not all of them, of course, just 1 or 2. So my body says, hey, we can't do that. We can't process this food. We have a problem. So the only way to do it is to send it right back where it came from. The first time I ever had an all, it was Demerol when I broke my shoulder, or sorry, separated my shoulder and broke my collarbone. And I threw up for like 3 straight days. They had no idea what was wrong. But I'll tell you, it was hell on earth, because they thought, because I started to throw up blood. If this is too gross, plug your ears. I threw up so much, there was nothing in there. So I just started to throw up blood. So I go back to the emergency room and they're like, oh man, this guy, he must have punctured his lung and had something wrong. So I had to get a chest x-ray. And I don't know if you've ever had a chest x-ray with a separated shoulder and a broken collarbone, but it is awful, because a chest x-ray, you have to hold your arm straight up above your head and push yourself against the wall. And my collarbone was not connected. It was the most painful moment of my life. And they're like, hold still. I'm like, oh. I was crying. I'm like, I can't hold still. I'm broken. Anyway, what? No, why would they? That's not as entertaining for them. Okay, I have like a 4-minute video we're gonna watch right now. It's on the other, it's already teed up, so we'll get that going. It's really actually pretty cool how enzymes work. You're allowed to, whoops, I always do that. You're allowed to not care, but you are required to be quiet.
Every single second, inside every living cell, thousands of chemical reactions are taking place. These reactions are performed by enzymes.
No, this guy went pretty fast, so I had to go.
An enzyme is a protein that catalyzes a chemical reaction.
Okay, hold on.
Every single second, inside every living cell, thousands of chemical reactions are taking place. These reactions are performed by enzymes. An enzyme is a protein that catalyzes a chemical reaction. It initiates the reaction, speeds up the reaction's progress, and makes sure the outcome is always the same. These enzymes often work together to form longer pathways, such as the citric acid cycle, which is a series of chemical reactions used by cells to generate energy from carbohydrates. The essential tasks of life, such as metabolism, protein synthesis, and cell renewal and growth, are all regulated by enzymes. The life-sustaining power of enzymes lies in the fact that they catalyze reactions in mild conditions of pH, temperature, and atmospheric pressure. The rates of catalyzed reactions are millions to trillions times faster than those of the same reactions uncatalyzed.
All right, so this is 8 zeros, so 0.00, whatever, there's 8 of them. And then this is a 2 with 3 zeros behind it. So 11 zeros faster. It's an unbelievable speed up in the rate when you have a catalyst. If we didn't have this, we would die as living things.
To speed up a reaction in the absence of enzyme, additional energy would need to be provided as heat, which jostles the substrates and occasionally provides enough energy to trigger a reaction. In the course of most reactions, an unstable and highly energetic transition state is formed as the substrates are transformed into products. An enzyme acts as a template for the reaction, binding to its substrate and holding it in the proper position to form the product. An enzyme also surrounds its substrate with reactive groups that stabilize the transition state, making it easier for the reaction to occur. To understand how enzymes work, let's take a closer look at a reaction in the citric acid cycle that is catalyzed by the enzyme aconitase. Aconitase binds to its substrate citrate and removes a hydroxyl group and a hydrogen atom to form the intermediate cis-aconitate. It then adds the hydrogen and hydroxyl back in slightly different positions to form the product isocitrate. In the active site, some amino acids are perfectly positioned to recognize the substrate and hold it in the optimal position for the reaction to begin. Some amino acids are involved in recognizing and holding the substrate. Other amino acids are directly involved in catalysis. Histidine 101 acts as an acid by donating its proton. Thanks to the chemical environment of serine 642, it can act as a base by accepting the proton from the substrate. The active site of aconitase also contains an iron-sulfur cluster that stabilizes the substrate electrostatically and helps to position it relative to the catalytic residues. The first step in the reaction is dehydration. In this step, histidine acts as an acid and protonates the hydroxyl on the substrate, allowing it to leave as a water molecule. Serine then acts as a base, extracting a hydrogen atom from the opposite side of the substrate, forming the intermediate cis-aconitate. Cis-aconitate then flips upside down, and the complementary hydration reaction is performed. In this step, histidine grabs a hydrogen atom from a passing water molecule, placing the resulting hydroxyl group back onto the substrate. Serine then returns its hydrogen atom, and the final product isocitrate is released. Notice that the enzyme itself was not changed by the reaction. It extracted a hydroxyl group and a hydrogen atom, and then put them back, thus starting and ending in the same state.
Okay, that was complicated. I hate biology, but I think it's an absolute miracle, to be honest with you. This chemical comes in here, it breaks apart, it spins around, it re-breaks apart, and puts the things in the right order that we need to survive as a human being. Like that is crazy stuff. Right at the very, very end, he said, notice the aconitase, if I am pronouncing it right, aconitase, not taste. It was the same before and after. It just came in, it grabbed some parts, took them off, spun around, and switched their location, and then it left the same as it was before, ready to do the same reaction.
This is the hallmark of a catalyst. When it finishes a reaction, it is ready for the next, so it can perform thousands of reactions in a row. Notice also that the shape of an active site is often flexible. Many enzymes surround their substrates, enclosing them to form the perfect environment for a reaction. Enzymes are fundamental to life on Earth, working every second of every day to maintain life processes in every cell in every living creature on the planet.
All right, every single living creature on the planet. So the importance of an enzyme really cannot be understated. It is a catalyst. That means it lowers the activation energy. That's what this picture is. This would be uncatalyzed. This would be catalyzed. Right. It lowers the requirement of energy so they happen. Because all those reactions could happen, but they'd happen slower and require a ton more energy. And so if we didn't have enzymes, we would require more energy to process our food than we got back. And that's a great way to lose weight, but eventually that will you would die. It would kill you. You wouldn't have enough energy to even process your food. Yes. Any way to what? Yeah, Mr. Parker, he eats like a 55-year-old human being. He eats this little shake every single day. It's like in a green bottle. I guarantee some of your parents take it. And it's a probiotic. Anyone heard of that? I don't remember what it's called, but what's that? You take it. It's good for you, but usually it's only old people that can afford it. So this is full of active enzymes that help speed up and regulate and make you feel better. Yogurt, okay. There's a U here, isn't there? Oh, whatever. Yogurt is also something that has a lot of enzymes in it. Milk, it's mostly dead, but the enzyme chemical can be in there as well. All right, I guess like every single day, this new unit, we didn't get as far as I thought we would. Hey, we had people. Hey, Ashton, good to see your name online. Sorry, I didn't know you were there.